So this is the conductors and insulators PowerPoint. Now you have a Google Doc to complete as we go through this. So pause the video, open up the Google Doc, and it's easiest to answer questions as you go along. Make sure you're also making notes in your book about the most important points. So conductors and insulators. In some materials, electric charge is not allowed, it's not free to move. So that means that current cannot flow. Conductors are the materials that do allow electric charge to flow, and metals are the typical materials that are good conductors. They allow electrical charge to flow. Insulators are materials that don't allow electric charge to flow, and an example of an insulator is plastic, but also rubber, glass, ceramics, all tend to be insulators. Now, why do metals conduct electricity? When metal atoms bond together, they lose or they free up electrons, and these electrons inside the metal are there able to move around. Now, we call them, in chemistry, we call them delocalized electrons, but these are free to move in amongst the atoms of the metal. So the electron moving can carry current because each electron has charge. Remember, charge moving per second is equal to current. Insulating materials don't have free electrons, so current cannot flow. Some liquids, like solutions that have salts or dissolved in them, or ionic solutions, are able to conduct electricity because they have ions with positive or negative charge, and these are free to move around in the liquid. So here's an experiment that we can do to see which substances conduct electricity. For example, if I take copper and I pop it in between the crocodile clips, I turn on the switch, the light lights up, because copper and other metals are good conductors because they have these free delocalized electrons to carry charge. Now you have a table in your Google Doc to complete as we go along. So switch off the circuit and let's take pure water. Now if I put some pure water in this circuit, does it conduct? Pure water does not conduct electricity because it doesn't have any charge carriers. It doesn't have any ions in it to carry the charge. Here I have solid sodium chloride. For those who are chemists, Na is sodium, Cl is chlorine. So here I have a solid sodium chloride powder. Does not conduct electricity, bulb doesn't light up, because the sodium and the chlorine are bonded together in the solid. They're joined together, so they're not ions. They're not free to move. Let's have sodium chloride solution. So this is sodium and chlorine dissolved. This does conduct electricity because when the sodium and chlorine dissolves in the water, they separate into the ions. Chlorine is negative, sodium is positive, and they can carry charge through the liquid because they're free to move around. Let's try, if we melt the sodium chloride and turn it into a liquid, is this going to carry charge? Yes, because when it's melted, the sodium chloride, the sodium and the chlorine, they break apart when it melts, and they are free to carry current. Try sugar solution. Sugar solution doesn't conduct electricity because sugar dissolves, but it does not separate into individual ions. Plastic toy. Does plastic conduct? No, because there's no free charge carriers there to carry a charge. Remember to pause this video and to note everything down. Wood. Does wood conduct? No. Again, doesn't have any charge carriers that are free to move. Glass doesn't conduct, so it doesn't have any charge carriers. An iron nail, of course, does because it's a metal, so it has free electrons. And Mercury, which is liquid, does conduct because it's a liquid, but it's a liquid metal. So in the liquid metal, there are 3 charge carriers to carry a charge. So there's a table in your Google Doc to complete that. Now, why do we need to know about insulators and conductors? Well, electrical cables, the metal on the inside is the conductor, which conducts and carries electrical current. But around the wire, we add a plastic or a rubber layer, which is an insulator, so it does not conduct. And this, for safety, does not allow the current to conduct into us if we touch the wire. And also, in these, we've got live, earth, and neutral. These plastic coatings don't let the 3 different wires touch each other, so you can't get the current from the live wire going directly to earth or going directly to the neutral. It has to pass through an appliance. So, got Google Doc to complete there. Off we go.